Hello again. Tonight we're going to talk about filtering NASA Global Coordinates Network and American Association of Variable Star Observers notices. Sounds like a lot of gobbledygook, and for most people it might be, but this is for those in the crowd that are looking for notifications of things like nova and supernova alerts. So I've done videos before on T Borealis and the potential for a supernova of Alpha Orionis, also known as Betelgeuse. Neither have occurred yet, but I want to be the first kid on the block to be aware so that I can get the word out to not only my group, but to other groups that I have familiarity with, and also to local government groups in case they were holding off on, we don't know how to hold a public observing event for something when we don't know when it's going to occur. Well, if I know exactly that it has occurred and can get them stirred up within a couple of days' notice, then maybe we can do some public observing. Now, I don't expect everyone to be fully astute in software engineering or a computer scientist. I'm sure that once I record this and edit it and post it publicly, that there will be an audience out there that is looking for this sort of stuff. Now, there's lots of videos out there about T Borealis and the supernova Betelgeuse, but there's not a lot on, okay, it occurred. Now what do you do? Or how do you know when it occurred? How do you know earliest when it occurred? So that's what this is focusing on. And I know there's at least one other group out there, Ames, Iowa, and the AAAA, Amateur Astronomy Group. They're also looking for this stuff. And they said, well, anything you can do to help us out, let us know. So I'm creating this video, at least for an audience of one. As the saying goes, time's a wasting. When a nova or supernova occurs, particularly a nova, the maximum brightness period is going to be fairly short. It may only be days to a week. If it's a supernova, depending upon how big it is and how nearby it is, it might be, for several weeks at best. It's always going to be, the supernova is always going to be brighter than it was for maybe a month or so. The nova, probably brighter than it was for a few weeks at most, but it's only going to be naked eye visible for a few days. So the idea is, if you want to work with local authorities to get them to expedite this, they're going to need more than a few days. So if I told them today, it happened today, it might take them, even at maximum expediting, the better part of a week to get their act together and get it promoted, because a lot of things involves services through outside vendors or promotional agencies, and they have to get the whole pot churning. So the more time I can trim off of me noting that it occurred to get the word out to them, the sooner the event can happen, and the more likely the public will be able to see a nova or a supernova at its maximum brightness. But I can't be like sending the word out and then go, oh, never mind, it was a false alarm. That would just be a waste of institutional resources. So there's an expectation that if I were to be the source of the alert to Fort Lauderdale or Broward County, local community governments, they're going to want to know it's a done deal, right? It's not like a false flag kind of thing. They're going to expect me to never raise the flag until it's actually happened. And, there's just a presumption without it being stated that whoever is going to be sending out the alert is going to be making sure it really happened or not. But how do you do that? So things happen in the universe, and they happen in various wavelengths. So when you think about, hey, I only want to see it when it's brightest. Are you talking about bright human visible? Are you talking about bright and high energy? Are you talking about bright and radio waves, gravity waves? What are you talking about? So when you go to say, well, I want to see when it's brightest for people to see it. Okay, so the brightest for people to see it will not be when it becomes bright enough for people to see without instruments. It'll actually be starting a day or so before that. So you have to look in more than just visible light. You have to look in gravity waves, radio, and we'll get to another one, which is neutrinos, because neutrinos will actually arrive at the Earth well before there's any other wavelength detection of a nova or supernova. And I'll get into why that's the case. But if you sign up for all these distributions, you're now going to have your inbox flooded And you probably want to automate that so you personally don't have to wade through every email going, is this it? Is this it? And, these sorts of observations may be for things other than what you wanted. Like did you know there's a supernova that happened this week? Not in our galaxy, in a galaxy, as the saying goes, far, far away, which can only be seen through the largest of telescopes. But a supernova happened in another galaxy this week. Throughout the universe, they happen quite often, not daily, not weekly, maybe not even monthly, but several times a year, you'll get supernovas in other galaxies. But that's not the ones we want. We want the ones that are local that we can see with our peepers. Sign up for a lot of stuff. You got to filter a lot of stuff out. As the saying is, we threw the baby out with the bathwater. If you have filtering going on, you better make sure your filtering is good filtering and not accidentally throwing out what you're looking for. So how you filter has meaning. Now, if you want to do it best, filter by hand by human beings. Actually, that's not the case. And it becomes even worse if you're having to filter through a deep wade of these things in order to find out what's good and what's not. The best approach is have an algorithm, implement it in software, verify that the software algorithm is working, and then apply that so that you get exactly the same analysis over every single email without, I'm tired, I didn't give it a good look this time and I missed it. Or, oh, I forgot to look for this because it's listed as that, not this. Well, you have to have flexibility in that. And despite having all the automation and having reviewed it and verified it, you still want to have a backup. And that backup is, well, if you miss the first kid on the block notification, if you missed that, you won't know you missed it until you missed it. So also be watching all those public science communicators, all the people that work in astronomy and physics and astrophysics and cosmology and particle physics, mostly of them on YouTube. But as soon as they're aware of it, you're going to see, because you subscribe to them, they'll tell you about it. And then you'll go smack yourself for having missed it because your filtering algorithm was bogus, but at least now you know it as soon as you could. So arrival order, what will hit Earth first? And the thing that will hit Earth first is neutrinos. So neutrinos move faster than light? No, they don't. The reason why neutrinos, and the picture on the right is of Ice Cube. That's the neutrino detector down in the Antarctic bed of ice. The reason why neutrinos will arrive first is they're far less interacting with other particles. So you can have dust clouds and planets and moons and other stars that get in the way of other kinds of particles and light, different wavelengths, even gravity waves. But neutrinos are so low in interacting that they pass through pretty much everything. So it's not that they're faster than light. Light will actually be delayed by interference along the multiple light years path, but neutrinos will just pass right through. The best way to describe it is when the nova or supernova occurs, there will be a condensing before the detonation, but the neutrinos will be created as the condensing occurs. They'll already be leaving. So they've got a head start on any of the other energy or gravity waves or anything coming out as a result of a nova or supernova. So they will arrive at Earth maybe hours to a day before the rest of it. So if you want to know the soonest, sign up for neutrino notifications by way of the place down in Antarctica called Ice Cube. Now, there are other neutrino detectors on the planet, but the one that's in full operation and has improved its sensors is Ice Cube. There are others that are going to come online next year and the following year, and there are ones that are online already, but they're not as sensitive and they aren't as big as Ice Cube. So when you sign up for these notifications, you want to filter the ones from Ice Cube as golden nuggets, because if Ice Cube says, I've got a nova or a supernova, there's a good chance it's not a false alarm. But now you need to find out where, because neutrinos actually pass through the Earth. So when Ice Cube detects something, it can detect it omnidirectional. So it may be neutrinos from the sun. It may be neutrinos from the supernova that happened earlier this week or one that hasn't arrived yet. So not only is it neutrinos, neutrinos from ice cube, neutrinos from where? You have to put all of that in the algorithm. So I said, well, I use Outlook for my email client. Years ago, I wrote lots of Visual Basic for Applications, or VBA. It's writing in, sort of an object-assisted basic that you can run. So you open up an email and you can have something run on it. It will analyze the email and then sort of tell you a conclusion. So that's the approach I took. It's not up to my usual corporate standards of software development because I'm retired. I don't have to work that hard. But I did write it. It's not thousands of lines of software. It's maybe 200 to 300 lines total. But most of it is the analysis of the emails. And I actually process both kinds of emails, the ones from NASA GCN as well as AAVSO. So lots of that. There's no higher order math. I'm just looking at values and numbers. Sorry, no calculus. The reason why I'm not dragging everyone through the actual source code is if I tell you algorithmically, not in a particular computer language, but just here's the stuff I was looking for, here's what I had to watch out for, then if you're running on, I don't know, a Mac environment or a Linux environment, and you want to do something similar, you can see what I'm looking for and how I looked at it, and then, go do it in Java or Python or, on Apple's script language or whatever you want to do. But I did this for a desktop, not for a mobile device. If you want to do it on a mobile, my eyes aren't good enough to look and develop software on something that small. I've got a big screen that I'm looking at. The difference between these two feeds is like day and night. The GCN ones can be hand entered. So there's a lot of variance in how somebody includes their flowery prose to describe things. And somewhere buried in that is the actual coordinates of what they're talking about or the magnitude of it, versus the AAVSO, the variable star observers. That is a nice computer generated, relatively uniform, with HTML embedded in the email. So it's easier to search through it. Rather than trying to wade through the raw data, I actually dig beneath it. For the GCN emails, I actually select a link and I get can you give me just a raw text version of this thing? So it's easier for me to search. And for the AAVSO, I actually break the email apart into its HTML, and then I walk the HTML objects. For those that understand such things, that's what you have to look for. So how do I filter it down? Well, the first thing I want to know is this about those two targets I'm looking for, T CrB and Alp Ori, which is Alpha Orionis, which is Betelgeuse. The next thing I'm going to look for is this an email from, gravity wave detection? Well, if it's gravity waves, nope, don't want that. If it's a gamma ray burst, nope, those will arrive later. The first to arrive is the neutrinos. So no gamma ray burst. Then the next thing is, the variable star observations are in a number of different filtered spectra. So I have to go through and, find out which brightness has increased. But also, when I get a coordinate, it won't be dead on to one of my two targets. It'll be in the general area. So I have to pick how wide a field of view can the rough first run value be? And then I have to, do the within range bullseye kind of thing. And if it's something like the variable stars, they monitor variable stars all the time for bright, dim. So they're always looking at it, and they're looking at it and logging and observing, even though it may not be at its maximum brightness. So I have to look at the brightness values and go, okay, it's not brighter than my defined threshold, which is about magnitude 7, which is just before human visible. So I have to monitor the magnitude. So it all narrows down to finer and finer and finer. And at the end result, you come away with a left or right turn and you go, thumbs up, it's 1, or thumbs down, nope, not 1. So I'm sitting in my Outlook client and one of these emails comes in, but usually I'm not right on top of the emails. So if I get a GCN notification email, I'll get 4 or 5 of them, bang, in a row, because I haven't sat on top of my email for the last 4 hours, and 4 or 5 of them came in. So I said, do I want to have to select one, process it, select the next one, process it. Well, it's easy enough in Outlook. All I did was I said, if I select all of them, and then I say, now go process it, in my software, I just have a little loop that goes, of all the things that you've selected, process every one of them. So it goes pretty quickly, about 2 seconds per email and done. But the first thing I have to do is say, hey, idiot, the thing you selected, is that an email? Because Outlook supports contacts and scheduling and calendar and all those kinds of things. And obviously these notifications aren't going to be those. So if I select the wrong thing in my inbox and it turns out to be a scheduling update for some thing I'm doing in medical devices, and I accidentally select that, it'll come up and say, hey, idiot, that's not an email. But I had to put in a check for that. Now, the best way to launch it is you select the items, and then up in the toolbar, the quick access toolbar, you just click on an icon, and it launches the script that does the analysis. I was considering doing it like a right menu, context menu thing, and then doing on that. But apparently they removed that feature in Outlook for security reasons. But the quick access icons are still there, and they'll launch a macro. So I did it with the quick access toolbar. Now, after I say, is it an email? Then the next thing I do for my processing is say, is this a NASA GCN or is this a variable star observation? Because the processing is going to be different because the email content is going to be different. So I had to say, okay, it's an email. Who sent it? Well, if the sender was no-reply@gcn.nasa.gov, hey, that's a GCN notification. And if it came from AAVSO at AAVSO.org, then that's a variable star observation roll up. So I can split the processing. If it's from here, do this. If it's from there, do that. So let's get into the NASA GCN specific processing. So the first thing I checked is this a gamma ray burst? And the way I did that is I said, well, why don't you give me the details of the observation and do it in text format, and then I can go in and pick out the things I'm looking for. And if you see over here on the right, subject. So if in the subject I see GRB, hey, that's a gamma ray burst. No, thanks. So I actually come up with a little window that says, that's a gamma ray burst. If it's other than a gamma ray burst, does it reference IceCube, my neutrino observatory? Not a GRB, but includes IceCube in the subject. The IceCube folks actually do that. They make sure they put IceCube in the subject, just like the gamma ray folks make sure they put gamma ray in the subject. Basic email stuff. Now, once I realize it's not a gamma ray, it's an IceCube, I go in and I find the right ascension and declination, not from 1950, not from 2000, but now, because I know what those coordinates are for my two targets. And I create a bullseye around those two and say, is what you're reporting, which may be a little off, because it's a raw observation, maybe a little off, is what you're reporting within my bullseye. If it is, so if it passes all these filters, to quote Annie Potts, we got one, as in Ghostbusters, remember that? We got one? Okay. So the variable star processing, remember this is an email chock full of HTML stuff. So the first thing I have to do is pick apart the HTML. Well, there's 3 tables in the email. I don't want the first table. I don't want the third table. I want that second table that has a very long set of rows, over 100 rows, and each one of them is a variable star observation. The first thing in the first column is, what's the thing they were observing? Were they observing T CrB or Alp Ori? If so, I want to pay attention to that row. If not, skip that row, go to the next one, and work down that second table from beginning to end. Once I find a row that I like, the next thing I want to do is pull out all the columns. I need to know, like, okay, that's my target. When was the observation? I want to know a timestamp. What filter band was the observation in? And filters can be kind of commodity names. There's a standard set of maybe 20 that people recognize, like red, green, blue, visual, those kind of things. But there's also observatory-specific variations of those filters that may be a very narrow wavelength. So I need the ability to find all the different bands of filters in these rows and then categorize them and run a statistical analysis on it to say, okay, of all of the visible, which one was the brightest? So I keep a running statistical analysis of it for each of the emails that I process. If I've got a new maximum, I also want to remember what the observatory was and what their comments were on that observation, so that when I produce my output, I can say, hey, we finally got it. It was from this guy at this time using this, telescope and observatory. I can do that, just hanging on the data. And of course, if it's brighter than my naked eye visible minimum, we got one. So when I get done analyzing an email, it'll either be thumbs up, we got one, or most of the time, thumbs down, this is not one of them. But now what do I do with that email item? What I wanted to do was, okay, now that I processed it out of my inbox, so to speak, I want to move it off to a folder where I can archive these things. For security reasons, Outlook will no longer let you write a macro that will scan email folders in order to move stuff to them. And they don't provide a routine for, I know where I want to move it to. Here's the entire path name of the folder. Move the email to there. I can write like plugins and stuff that would run in Outlook, but that's, as the saying goes, too much like work. So I just said, I'll mark the email as no longer being unread. In other words, the email has been read when I processed it. And I can manually, now that I've got them selected, just block move them into an archive folder. A better way to do this, but it's not available because this kind of macro filtering stuff is really a brute force approach to doing it, would be, hey, if they had a database and they had all the right columns in the database to like conclude by a criteria filter, this is it, and send me one email only when it occurs. That would be great. But the services that they're providing me don't do that, because the people that are creating these services, they're the observers. They're not like computer science subject matter experts. They got some raw like data, and they want to punch that into a system, and then the system will send that out to their fellow observing professionals, and they'll get that email and they'll process through it because they respect and manually process every single email they get in their inbox because they're all about professional observing. Me, on the other hand, I've got a lot of other email I got to process. So I'm going to have to process all this stuff. If there were less garbage coming in, the process would be easier, but I don't presume that to be the case. Just to give you some of the sort of nuance, in the ones from NASA GCN, part of the coordinates is the right ascension, the RA. Now, how is that tag indicated? Is it RA? Is it R period, A period? Or is it SRA, source RA? It's any of those. So when I go looking for it, I have to look for it as any one of those. Now, when you get the RA value, amateur astronomers know that to be, hours, minutes, seconds. But professionals don't think of it that way. Professionals think of it as fractional degrees, one value. So their unit of measure is degrees, whereas amateurs' unit of measure is sexagesimal, hours, minutes, seconds. So I have to have conversions for these things so I can understand it in the way I know it, because I've got the RA and deck of my targets, and I'm getting fractional degrees as a unit that I have to convert to RA and deck in order to go, is it within the bullseye? Little nuances. And then sometimes when they are manually entering things, they go, well, I didn't quite get magnitude 8.5. I think it's actually brighter than that. So when they put the number in, they don't put the number 8.5 in. They put in less than 8.5. I can't parse that as a numeric value. I'm sorry, that's not statistically pertinent. So I have to look for things like less than and greater than characters and like human entered stuff like that. But like I said, if there was less garbage in, it'd make the algorithms easier, but I'm fine with how they are now. I can have my complaints, but I'm fine with how they are now. So in conclusion, if you want to be the earliest on the food chain, you have to go through these slings and arrows of filtering things out and false alarms and the variability of it all. I wrote an Outlook VBA. It's actually some subroutines and filters and a class for handling the filters. And if somebody's really into this stuff and they've got some expertise in either writing VBA or on some other system, but they're actually a software developer, if somebody really wants a copy of these things, I'm not going to claim any proprietary ownership of it. As the saying goes, it's open, it's as is, no support, but modify it as you see fit. Learn from it, go write something different. I'm fine. But if you're going to use it with Outlook, I strongly suggest you have some VBA macro developer experience, especially if you want to do things like hook it into an icon on the quick launch toolbar. There are administrators that go, I'm not going to let anybody run any VBA macros on my Outlook because it's a security threat. Fine. If you want to do that, then deny your user the ability to do this, and they'll have to read all the emails. Or send an email to me and I'll add you to my list when these things occur. Or they can run it on a separate computer that's all that computer does, so it's not going to infect any other computers, but that would cost obviously the computer. I'm not going to waste that kind of resources because it's my home environment. I protect it through several security means already. I'm not worried about running a macro I wrote. Okay. And links. I have a link to the YouTube video that I did telling you about the nova and the supernova. A link to what is this NASA GCN thing and the AAVSO folks. And if you're not familiar with Visual Basic for applications, but you've seen software before, here's a link to where Microsoft has some very good documentation on the programming environment. Don't be afraid, it's only software. And then if you didn't know what a nova was, nova, T Corona Borealis, Alp Ori, the electromagnetic spectrum. What is this stuff he's talking about? Gammas and X's and UVs and stuff. And then why neutrinos arrived first. And look at that. It's from FNAL. That's Fermi Labs out of Chicago. It's your tax dollars at work. National Science Foundation. Okay. I knew this wasn't going to take long. I knew it was not everyone's cup of tea, but I wanted to get it out there in case there are others out there that are sort of feeding on this frenzy of notifications coming in from these various sources going, is it soup yet? Is it soup yet? Is it soup yet? I promise not to do these sorts of things on a regular basis because I just don't think it's something that is going to keep my audience around. But I didn't mind doing that for this special, hey, we're looking for a particular nova, and it's going to happen this year, maybe any day now. So I thought I should expedite getting the software written to do this. Anyway.
I had two comments.
Yes.
One is, as I don't remember what city you said that is preparing.
I actually did a presentation and discussion with the Ames, Iowa Amateur Astronomers Group.
We have to give them a compliment that they're doing this, that they're looking into it ahead of time. That's one. And the second thing is on page 3, I think it was, of your presentation, screen 3. There it is.
Yeah.
I wanted you to explain this picture because there's no explanation on the picture.
It's just a graphic. It's just a graphic to draw your attention.
And it did do that, but I was wondering.
People are accustomed to seeing the electromagnetic spectrum horizontally.
Yes.
Okay. You see the very colorful little like orange to green to like violet in the center. That's the visible spectrum.
So the visible is the purple area.
It's from orange to purple.
Okay. Now, when you're looking at the other side, that's energy level?
That's the wavelength. And the wavelength, when it's smaller, is higher energy.
Mm-hmm. And so we can see it when it's not at the highest energy.
Correct. So in the middle, you can kind of see what you look at as sort of sine wave kind of things. The normal, like you can see from peak to peak. It's narrow, but not too narrow.
Okay, I wasn't sure where we saw it at, where it started and
The color
ended.
bands there on the right.
Right.
Mentally rotate that diagram
Yeah.
90 degrees to the right. I
Right.
rotated vertically so it would fit on the slide. Because I got
It's
lots of
pretty-
text there.
And then that's an energy wave, or it's not an energy wave.
The wave is the electromagnetic wave of the photon.
And is that energy or not energy? It's a wave
momentum,
that-
the momentum of the photon is measured by its energy, and as the frequency gets smaller, the energy goes up. So, for
Okay.
example, ultraviolet is a narrower wavelength, higher frequency than is radio. So the wider stuff down at the bottom there would be like radio. The higher end stuff at the top would be like gamma rays. And
And that's where the
is
neutrons
visible.
are. The higher is the neutrons.
Uh,
Neutrinos.
neutrinos aren't even on there because
Oh.
neutrinos are not an electromagnetic particle.
Right. Yeah.
You
Neutral.
mentioned that.
They're neutral. That's why they don't show up in the electromagnetic spectrum. Is they're neutral. They're less than atomic. They're not protons, neutrons, and electrons, or they're anti-counterparts. They're a different kind of particle. But they do pack
They're
energy. But they're
Okay.
just not light.
So
I
they're
think, I think of neutrinos as if light didn't interact with something, you could fit neutrinos on this scale. But neutrinos would be way off the top because the amount of energy per neutrino is higher than light.
Okay.
But they don't interact with anything. So, millions of them are passing through you right now. You don't even notice it.
Right.
I know it.
You can feel every single one of them.
Joe knows it.
No, you're just like me. You're
I caught a
feeling the
bunch
old
of
age.
things. Yeah.
Okay, so that's the electromagnetic spectrum, and the visible
I
part's
thought
right there in the center with all the colors.
Yeah.
What we can see.
Well, thank you.
With
That's
our eyes,
all we can see without technology.
the damn
Once you add technology, we can see all of it.
we're not
There was
doing too much.
Remember, you don't have to subscribe to these email floods, and you don't have to be running Outlook VBA scripts because I do all that stuff. And if you're on my BA distribution list, trust me, if a nova occurs and I'm aware of it, and
We
I
will know.
think it's gonna actually happen, you'll be aware of it too.
Yes.
And then about 2 days later, every public broadcast will be talking all about it, like as if it's the end of the earth.
Yeah.
And
Yes.
for TCRB and for Betelgeuse, neither one of them will be the end of the earth. In the case of TCRB, it'll be a couple of nights of a new bright star and they'll go dim again, and that'll be it. In the case of Betelgeuse, we might get some good auroras for a few days, but that's it. When Betelgeuse goes supernova, it will change our night sky for the rest of our lives.
Yeah.
What was a bright red star in the left shoulder of Orion will become a giant bruise, a supernova remnant in our galaxy. Whenever it occurs, maybe not in our lifetime, but whenever it occurs, it'll go from a bright red star up in the shoulder of Orion to like a nebular cloud that looks fairly bright. And they say that when Betelgeuse goes nova, you'll be able to see it in the daytime for a couple of days.
Oh,
That's going to be bright.
Yeah.
But even when you can't see it in the daytime anymore, it'll be naked eye bright at night for about a month.
super.
And then
Yeah.
it will disappear down to a white dwarf, and all you'll see is the nebular cloud. But like you look at M42, the Orion Nebula, and you think, oh, that's really nice looking. When you look at the Betelgeuse Nebula, it's going to be even more ostentatious. It's going to be bigger, have more colors in it, and be brighter than the Orion Nebula. It will change our night sky.
Hmm.
Well, thank you very much.
Okay,
Appreciated it.
we are recording. I'm going to stop recording at this point.